Recording. So good afternoon, everyone, and welcome. So my name is Joanne Fradaccio. I'm the Education and Events Manager here with Quality, and we are so proud and happy to be bringing this exciting webinar to all of you today on building resilient homes, strategies for flood, hail, and high wind protection in Ontario. We do have people tuning in from across Ontario, but also outside the province. So I'm sure that some of this information will be very relevant to all of you. And we want to thank our partners and sponsors, Moen and Mainline Backflow products, as well as cooperators for making this webinar possible. And we will be sharing more information with all of you as we move forward. So the presentations after this presentation wraps up, everyone will receive an email that will have links to the presentation deck so that you can also have that information as references. But please note that the materials are owned by, of course, our presenters. So please take that with a little bit of information there. And also you will be able to connect with each of our presenters too. We'll make sure that their contact details are included in the post-event email. So without further delay, I would like to talk a little bit about us, about Quality. So what we do, of course, many of you are familiar with Quality. We are Canada's #1 certifier of energy efficient homes. We provide, of course, quality assurance, program administration, and education and custom training, as you see today. And there's a great big list of the different types of custom education training that we provide. And we're very proud to be doing that for over 26 years now. So for our builders as well, there's always the best fit in terms of labeling and certification for all of you. So there are different label options, the Energy Star, Guide, R2000, and of course the Net Zero label. We partner, of course, with CHPA on that. And we are very proud that we have a growing number of Energy Star multifamily buildings as well that are being certified. So in terms of housekeeping today, so all of you familiar with Zoom, or you might be familiar with Teams, but Zoom today we have Q&A. So there is a Q&A function in the bottom. There's also that reaction area. There's also the chat function. So please use the chat function to communicate mostly with me if you have any technical difficulties. For Q&A, please don't be shy. You can ask your questions anonymously. You can ask them with your name. So that is also very welcome too. So our facilitators know who is asking the questions. And we will take a break halfway through. We're going to probably take a 5-minute little stretch break so that our presenters can also get a little hydration too. So please ask your questions. We will hold on going through the questions until after each section, but please do ask those. I'll be monitoring them and we'll be pausing throughout to make sure that all questions are answered. So please don't be shy about that. If it's about a specific topic, just please also note in your question, like which topic it's about so that I know that when we come back to wind, that's what it's about. And as I mentioned at the beginning, an email will follow up after the webinar wraps, probably within a couple of hours before end of day. You'll receive an email just with different links for the presentation, for the survey. We really do appreciate your feedback. It helps us as we deliver more of these sessions to all of you. And also it's going to have contact details for our facilitators so that you're able to reach out and ask them any follow-up questions. So here's the agenda, what we'll be going through. We're going to get through some introductions, then we're going to dive into wind, high wind impacts and protection options for Part 9 homes. We're going to do a little Q&A. Then we will introduce our friends from Moen and also Mainline as we lead into the conversation about flood and urban flood impacts and basement flood protection options. Then we'll take that little break after some Q&A, and then we'll dive into hail and hail damage and available protection options for Part 9 homes. And then, of course, we'll introduce our friends from the cooperators so that we can talk a little bit about resiliency incentives and stronger home protections, and then open the floor up and do a little bit of wrap up. So pretty engaging, pretty self-explanatory. So What I want to do is jump into some introductions, and also for all of our audience too, we are going to ask you a couple of questions too. So just stay tuned for that, and we want to make sure that everybody's paying attention too. So without further delay, I'm going to give Dan Sandink, who is the Director of Research at the Institute for Catastrophic Loss Reduction, a moment to introduce himself. Thank you so much for joining us today, Dan.
Sure. Thank you, Joanne. Thanks, Joanne and Greg and the team at Interquality for setting this up for us. We're hoping that this is going to be sort of an initiation of an ongoing conversation we can have with participants. Part of our objectives at ICLR is to engage more directly with the building industry, builders specifically, to learn more about ways that we can implement resilience options. We understand that we have to sort of provide practical solutions that builders can actually apply in the field. And this is part of the process that we think is an important part of the process, getting in front of the right people. I wanted to quickly note something that Greg and Simon and I, while planning the presentation, thought we should point out why we're talking about these topics. So the reason why we're going to focus on residential construction today is that's what we see as the major driver of disaster loss in Canada. So we have about 2/3, typically for most disaster events, of losses are caused by Part 9 residential construction, personal property loss. We're talking about buildings, contents, additional living expenses associated with people being displaced. And that's the reason why we've focused on this topic. Another thing I should note about ICLR is that we're partly funded, about 50% funded by the P&C insurance industry. So we have close linkage with the P&C insurance industry. And thanks to cooperators for participating today. They're one of our important partners. And we have heard from our membership over the years that Part 9 construction is a priority with respect to disaster loss. And that's why we've focused our work on that topic over the past couple of decades. From 2014 to 2023, the insurance industry saw $14 billion in losses, largely attributed to hail, urban pluvial flood, which I'll talk about later on, high wind, and wildland fire. Those are the four major drivers of loss. We're talking about three of those drivers of loss today. Initially, we're thinking about a Southern Ontario-focused workshop. Now, I think it's more national. We could talk about wildfire in the future as well. But that's the reason why we're focusing on those topics, because those are the major drivers of disaster loss in Canada. I should also note that 2024 was the worst year on record. So from 2014 to 2023, we saw $14 billion in catastrophe losses for the insurance industry. To date, in 2024, we're not even through 2024 yet. We've seen $8.4 billion in catastrophe loss. So this has really raised the profile of this topic for the insurance industry. And we're increasingly getting questions from the building industry as well about how to build more resiliently. And we hope to address some of those questions or at least start the discussion today. So thanks again, Joanne. I'll pass it back to you.
No problem. Thank you very much, Dan. So I'm going to pass things over to Professor Greg Kopp to do a little introduction about himself too. He is the Professor of Civil and Environmental Engineering at the University of Western Ontario. Greg, over to you.
Thanks, Joanne, and good afternoon, everyone. It's a pleasure to be here. I've been working on trying to mitigate the effects of extreme wind on the built environment, particularly houses, for over 25 years now. We do things from wind tunnel testing. We do full-scale lab testing at something called the Three Little Pigs Project, and we do damage surveys across the country from severe storms, including tornadoes and other kind of wind events. I've served on building code committees in Canada and the US, and I'm passionate about translating what we do in the university into practice so that we can reduce the losses and damage caused by these storms. I'll stop there. Thanks, Joanne.
Okay, perfect. Thank you. We'll hear more from Professor Greg Kopp shortly. And I'd also like to invite Simon, who will be one of our speakers as well. Simon, research meteorologist, Northern Hail Project, Department of Civil and Environmental Engineering at the University of Western Ontario. That's quite the long title, Simon, but I'll give it over to you for a little introduction.
Thanks so much, Joanne. So just to mirror everyone else's comments, thank you so much for having us. For providing an opportunity to have this discussion with the folks who can make a difference on this issue. So just in terms of quick background, I am the research meteorologist with Northern Hail Project, which is a component of the Canadian Severe Storms Laboratory. here at Western. And just in terms of background, I'm coming out of about 12 years as a consultant working in the climate and extreme weather risk assessment space. I wonder why someone might focus very specifically their career or at least the job on a particular hazard. And in this particular case, I joined the hail research here at the CSSL. Specifically because as a consultant working on high impact climate severe weather events for 12 years, I noted that hail specifically was a very understudied hazard. So there was an opportunity here to conduct some research. As Greg noted, among the work that we do here is research in terms of going in after severe events, high impact events, and assessing the impacts and documenting the damage from these storms, and in trying to learn something from it in terms of what we can do to mitigate those impacts. And so that's my current role here. And you'll see some of the initial results of that research later today on the talk. So with that, I will pass it back to Joanne. Thank you.
Awesome. Thank you so much, Simon. So we will do an introduction to our other presenters, our sponsors. We really do appreciate that they're here. I'm going to give them a special introduction, but right now I will give a little bit of a highlight. We have Jerry Fairborn here from Moen, and we also have Michelle Laidlaw, who is joining us from Cooperators, and we also have Gabe, who is joining us, James Corsicella, who is joining us, of course, from Mainline. So as we have everybody in the room, we have about at least 40, 50 people in the room, which we absolutely love. We would love to know a little bit about you. It gives our presenters also an idea, and it gives you as attendees an idea of who's in the room. So we're putting up this poll here on your screens. Hopefully you can all see it. We also realize that all of you wear more than one hat. So please, you can multiple choice here. Our presenters, unfortunately, you can't respond to this survey, but that's okay. Please take a few moments to tell us your profession and whether you're an architect, energy advisor. We might have some consultants in the room. We also might have some building officials as well. So let's take a couple of extra seconds just to fill this in. And I will close out this survey in about 10 seconds. Give everybody kind of a clock. Sometimes I wish I had a little bit of a Jeopardy timer here or the Jeopardy theme music here, but I think I have to pay for that. So, all right, we have just about 100% participation. That's fantastic. Everyone is in here. So I'm going to close this out now. I'm going to share those results. So to our presenters, our facilitators, and to all of you in the room, you can see who we have joining us. It's quite the selection, quite a variance here. We have some architects for sure, about 30% of attendees. We have some energy advisors as well. That's the other big chunk. And also project managers. If there is any other, if you want to drop that into the chat, what that might be, we are always eager to hear. And we also have, of course, some builders and consultants. So that's wonderful. I'm going to stop sharing that. The next question I want to ask all of you is, where are you coming from? Whereabouts are you joining us from? Are you joining us from Ottawa, Toronto, Calgary, Edmonton, Southwestern Ontario? Let us know. Put that into text. We would love to have that, and I will make sure that we actually get that shared too with all of you. So please do take a few moments. I understand too that when I was looking at the registration report, we were having individuals join us as far east as Montreal and as far west as Edmonton, Alberta, which is absolutely fantastic. So really a wide scope of individuals joining us. So I'm going to leave that open for just another 3 seconds because I know we had another couple of people join us in the virtual room here. So I'll give you guys a second to respond to where are you joining us from. And I'm going to close this out right now. And I will share those results as soon as I can, actually. And it's gonna, for me, it's gonna open up in a different window. But I will drop that into everyone. So we have responses from Barrie, Toronto, Ottawa, the GTA area, near Winnipeg, Manitoba. That's great. Peterborough, as well as a lot of people are coming to us from Toronto. We do have those coming to us from Edmonton. So that's great. Ottawa as well, Guelph, and Kitchener area. And yeah, there's really a big scope here, as including Oakville as well. So thank you very much, everyone, for responding to that that question right there. And I'm going to put back up our presentation here so all of you can see. And I'm going to stop sharing that one and come back. And there's one other question that we want to ask before we dive in, everyone. So I'm going to stop sharing for a second and go back into my presenter mode and share my screen so all of you can also see this. Okay, great. So the last one that we want to ask all of you joining us today, are you currently implementing resiliency measures in your building projects? So yes, with a few projects, all of your projects moving forward? No, not yet. I'm here to learn more about them. That's why I'm here. You have been thinking about it is another option. And of course, there's others. So let us know in the chat what you are doing as well. So please let us know. That's a great question that I just noticed come into the chat, Peter. So I will make sure, I'm sure our presenters will be able to see that as well in the chat area. So I'm sure one of you will put up your hand to let me know who is going to be the best person to answer that question. In a hot minute.
I can give
You're
a
going to
response.
address that, Dan?
Yep. So
Okay.
we can do that for you for sure.
Yeah.
Part of the issue is that we're collecting data from Cat IQ, and it's kind of it's a proprietary resource, a subscription-based resource. So we can provide some detail, but not a great amount of detail publicly. But Peter, if you want to connect, we can for sure provide some more detailed metrics.
Awesome. Okay, great. Thank you so much. Okay, and everyone, I'm going to close out this poll so that we can really dive into the conversation. So I'm going to end this poll right now. I'm going to share the results so all of you can see, hopefully. So that's great. So for some of you who are joining us, about 25%, you're saying yes, you're using some resiliency measures on a few of your projects. The most part of the room, you're not doing that yet, but you're here to learn more about it. So that's really great. We really do appreciate you all joining us, and that many of you have also been thinking about this. So that's wonderful. And really about delivering education to homeowners. I think that that's really important as well. So thank you all for joining us and taking part. And what I want to do right now then is not dive in yet to Jerry, but I'm going to stop sharing my screen and I'm going to give the floor over to Professor Greg Kopp and to Dan so that we can dive into everything about wind.
All right.
Perfect.
Well, good afternoon, everyone. Again, it's a pleasure to be here, and I'm going to be sharing the floor with Dan today. I'm going to talk a little bit about what we observe following severe windstorms, so you have an understanding of what kind of resilience measures we actually need when severe wind hits our homes, and then Dan will talk about those details. All right, so you already had my title. So what I want you to take from my part of the presentation today is to have an understanding of what actually happens when we have severe or extreme windstorms in our communities. So what is the damage that's typically observed? In particular, there's three issues that I think are important. Roofs are very vulnerable in houses, so I'm going to talk about that. Walls are also vulnerable, but they're partially vulnerable from windborne debris. So when stuff fails on the roof, it breaks the stuff on the walls, and that causes cascading damage in our community. So I want to talk about those three aspects, and hopefully this will be clear to you as we do it. So this is a typical kind of photo, a kind of image that we see when we go to post-event damage surveys. This was a very large, devastating tornado that was in Manitoba, actually. But this was on the edges of that in regions where the wind speed was much lower. And this is the kind of damage that we see typically in any kind of severe windstorm once winds get over 100, 120 kilometers an hour in that kind of range. We see shingles off everywhere. Roof sheathing comes off, soffits fail, vinyl siding fails, and windows get broken. One of the interesting things that we've learned is that if there's enough wind for the shingles to actually fly through the air off the roof, they have enough energy to break typical windows in residential construction. And so you see broken windows as soon as there's shingles and stuff flying around. So this is one of our common observations. Roof sheathing is actually really important to the performance of houses and how the homeowners get on afterwards. So when you lose a panel like this, you can have lots of water entry. Our windstorms tend to be accompanied with rain. And so once you start getting rain through an opening that kind of size, it causes a lot of damage. This is a case of a sheathing panel. They lost a sheathing panel on the second floor, and this is down on the main floor, 1 story below, and that's the kind of water you can get into houses. So keeping the roof cover on and the water out is one of the really important things. So even if the storm isn't so devastating that it destroys the house, the water entry can do a lot of damage. One of the really big issues with wind is the uplift. So when wind blows around a house or any kind of low structure, it causes uplift on the roof. This is the same physics that gets an airplane into the air. So an airplane going down the runway speeds up. The pilot changes the angle of attack. It increases the lift, and the plane goes in the air. When wind blows over the roof of a house, it wants to lift it up. And wood frame houses have very lightweight roofs. The trusses don't weigh very much. And so what's holding them down are the nails. And so those nails that connect the roof to the top of the walls are very important to house performance. In fact, this is one of the weak links in our structures. So if you have a house built perfectly to the building code, the roof structure is actually more vulnerable than the sheathing. Our work in the labs and analysis shows. So this is a common kind of failure we see in extreme wind events. And so again, just thinking about the roof structure, the trusses or rafters are attached to the top plate. Those walls get attached to the floor and onto the foundation. And we need to remember that when wind is acting, the wind wants to lift the whole thing up. And so we have to think kind of counterintuitively about holding it all down and in place. And this is one of the key takeaways. And so there's simple measures that can deal with this, like hurricane clips and 6-inch truss screws are really good, but they're really effective at holding the roof down. So that's one of the things that we need to consider. The other thing that makes the vulnerability of roofs worse is when we have broken windows or broken doors. And what happens is the wind can rush in, and it's like, you can imagine, it's like filling the house up like a balloon. So it wants to push out in every direction. It wants to push the back wall out, but it wants to push the roof up. And that gets combined with that wind going over the top of the house that wants to lift the roof up. And so a lot of the roof failures are associated with something happening in the walls. And often that's a debris shingle or a 2x4 or something going through a window or door, causing an opening and making the houses more vulnerable. This is an example from a tornado in Vaughan, and these poor people, their door wasn't latched and it blew open. It was in a tornado, but their door wasn't latched. You can see their clothing still in the closet there, but the roof is off of the house. And so this is a complete write-off for them, and they'll be out of their home for a while. This is their neighbor, literally right beside them. They didn't have any broken windows, broken doors. All they lost was shingles and the whirlybird off the roof. So they have a very different scenario after the storm, just from that simple case of opening the doors. Once those roof structures fail, you start to see a lot of debris getting blown around. This is particularly catastrophic in tornadoes, but it happens in all windstorms. This is a picture from Goderich from the tornado there a while ago. All those 2x4s going through those truck windows, pretty scary, I think. Someone was actually in that vehicle in the tornado and they were not injured, which I think is a bit of a miracle. But this is one of the key issues. And just for fun, Goderich had a lot of old brick buildings, so the bricks, of course, flew as well. But this one, the brick was flying nearly horizontally. It went through the inside and is emerging out from the inside. So it went through the driver's door. You can see the broken window there, and it came through the inside. So debris is one of these really serious things that we have to think about in windstorms. And to the extent we can reduce it, it makes a difference. Here's another example, 2x4s from roof failures going through walls. You can see the windows are badly damaged in these houses. You can see here again all the impacts of debris onto various surfaces. In these cases, in this particular one, the house on the left lost its roof as well as part of that damage. So the debris is a big issue and causes a lot of the damage. Here's a case, someone left their garage door open during a storm. That led to the failure of their garage roof, and that roof landed on the neighbor's house. It took us a long while to figure out what happened here because that corner of that house is not a kind of failure that you see. You can see the shingles off of the roof. That's the high wind. But this roof truss in the middle of it is from the neighbor's garage. It just flipped over and did that kind of extensive damage. And so we have this cascading effect of damage in storms that we want to be able to mitigate. I want to talk, so I've talked about roofs and talked about debris. I want to talk a little bit about how we also need to keep the walls connected to the foundation as one of the critical things. So this is from Barrie. There's another tornado there in 2021. Barrie, of course, got hit in 1985 with a devastating tornado that killed a large number of people. It got hit again in 2021. You can see, again, typical damage, sheathing failures in many houses. Here's a house that lost its roof, but this one in the foreground, the first story, it was a two-story house. The first story collapsed, and again, no one was injured in this, which I think is amazing. But you can see that level of damage. And when you take a closer look, which our team did, the fasteners from the walls into the foundation were actually inadequate and didn't meet code in this particular case. And this was one of the outcomes of that. If there had been proper connections or fastening there, this house would have just been like its neighbors, sheathing off, shingles off, and a bit of that kind of cladding damage. So these little details, the nails are really crucial, how we fasten. For fastening to the foundation, the bolts that are in the code are really important. So just by way of final comments before I pass off to Dan here, as we have strong windstorms, the issues tend to be around the cladding, shingles, siding, soffits commonly fail. This can lead to further damage from water entry. Also, those things flying through the air, shingles flying through the air can damage downwind windows, which can also make the house vulnerable. The roof is really important in windstorms. We need to keep the sheathing on. We need to keep the entire roof structure on to reduce the losses. So we need to think about the loads going upwards in the storm. We need to think about pushing it over, but that's maybe more intuitive, but that uplift is a critical part. And if we can reduce damage in houses, we can keep the community less damaged as a whole, and it allows us to protect openings and reduce the likelihood of the roof failing. So with that, I'll stop sharing and pass over to Dan.
Okay, thanks, Greg. So my second part of this discussion here is going to focus on resilience options for high wind with an orientation toward practical resilience options. We've been working in partnership with CHBA and a number of builders over the past few months on working through resilience options as presented in existing standards and guidelines, and finding opportunities for implementation of more practical, low-cost, low-risk options in the near term as we sort of work toward more scaled-up resilience implementation in Canada. I'll start here with wind, but this will set up the discussion for basement flood as well, and eventually hail, wildfire. We're still sort of in the early days of this work, and part of what we'd like to get back from this group is feedback and potential additional discussion if this presentation is of value to you. So with respect to high wind protection options for Part 9 buildings, there was a standard that was released in 2022. Professor Kopp and I were involved in writing the standard, and I think some other folks on the line as well. It was geared toward addressing some of the primary vulnerabilities of Part 9 construction that groups like Professor Kopp's and others in North America had identified based on lab testing, wind tunnel testing, field surveys, and so on. It's a large, complex document. It's oriented toward EF2 level protection for Part 9 buildings. On the right is an image indicating all of the elements or the categories of elements that are covered in the standard. The standard covers both structural components of the building. So we're talking about vertical load path, tying the roof structure onto the building and the building to the foundation, and also non-structural elements, so cladding, roof cover, siding, windows, and so on. So one of the feedback that we've been getting from the building industry is that we need to think about tiered implementation of resilience options. And that's been one of the areas that we've been working on with a partnership with CHBA that was sort of under the guise of what we're calling the Resilient Homes Task Force. This is a group of building industry executives and insurance executives working on building capacity in these two industries for resilient construction. The feedback that we've gotten is that we should focus initially on high impact, low cost, low risk options for builders. And that may include, in many cases, options that builders are already applying in some parts of Canada. So our criteria are, and we're breaking these out into three categories. We're calling them good, which is basically a sort of basic category, a basic level of resilience. Better, which builds on this good category, and then best would be full application of more complicated standards. With respect to good options or basic options, these are options that address recurring vulnerabilities. So we see them day to day. They don't always sort of trigger, say, a damage inspection like from Greg, from Professor Kopp's team, but they result in insurance losses. They are options that are low risk, as I said, low risk, low cost, low complexity for builders. They're technically mature. That means they may already be referenced in codes, but not widely applied. They're supported by standards, in some cases more mature standards, and may already be applied in some jurisdictions. And I think it's also important to note, especially when we talk about urban flood or pluvial flood, that the good options are those that are independent of municipal side action. And that's really relevant for wildfire and basin flood, because there's a lot of municipal side or landscape level work that needs to be done for resilience. Our options focus on what can be done on the private side of the property line. And then, as I said before, better, it could be more expensive, it could be a little bit more complex, but it provides additional resilience benefits. And then best, we're not really concerned with cost and complexity, we're concerned with the performance of the building during an extreme event. So just to illustrate the concept a bit further, so we have our three categories, good, better, best. The light green, good, dark green, better, the blue dot is best. As you progress in wind intensity and wind speeds, the type of damage that the building experiences becomes more severe. At lower wind speeds, you tend to get damage to roof cover, to cladding, downspouts, that sort of thing. But as Professor Kopp mentioned, even minor damage to roof cover can result in significant damage to the building if you get water intrusion into buildings. And certainly we've seen, for example, in Barrie, buildings with just roof cover loss with $200,000-$300,000 claims. We're expecting it's because of water intrusion into the building, and perhaps you can hear more about that from cooperators later on. The CSA S520 standard, so what we're classifying as the best option, that's the blue dot. It is targeted for EF2 level damages, which typically includes loss of the roof, loss of upper story walls. And that's what we're targeting for our best option. So if you want full protection for EF2 level wind events, or sort of a more serviceable building after an EF2 level wind event, you would have to apply the best category of options, or the full S520 standard. But we can make a difference by addressing some more simple components of the buildings, like roof cover, like secondary water barriers, cladding, and so on. So our aim with these categories is to introduce resilience options to the building industry in a way that is digestible in the near term. These are all voluntary options. They're not in construction codes. We want builders to start thinking about application of these options. We know we can't do it if we only have an option for the full set, the full standard. And so we're working to prioritize these options. So for our first iteration of our tiered categorization for high wind, we have good, better, best. If we look at the options that are presented in CSA S520, it covers the range of building components. For our basic category, our good category, we're focused on enhanced roof cover, secondary water barrier, fastening of sheathing panels to the roof structure, and other options that the building industry has told us are not terribly complex or expensive, and that includes roof-to-wall connections, so truss to top plate to stud connections. If we move on to the better category, that would extend beyond just the roof and roof-to-wall connections to the full vertical load path, because that's the next most important element, is transferring that uplift load from the roof structure down to the foundation. So we're then talking about wall-to-wall connections, lower story to mud sill, sill to foundation connections, as well as some other options that are more widely applied already, but more expensive. That includes better wall cladding, and vents that are more resistant to high wind. And if we want the full set of options, the resilient options, then we are applying the full S520 standard that includes all of these elements. So in the interest of time, we've only got a few minutes today. I'll focus on the basic, the good options and better options. I should also note that as part of the work with CHBA in the building industry, we're reaching out to the building industry to get a sense from them what they consider to be practical. And so, for example, we are running a survey, or we'll be continuing to run surveys that we're running each of the resilience options past builders and insurers. We're asking builders, how likely are you to apply these options in the next 5 years? And we're asking insurers what impact you think this will have on resilience. Do you think it'll have a significant impact or a minor impact? When we put the results of those two responses together, so how likely are builders to implement, how much impact do insurers think the option will have on resilience? This is the table that we've had so far from our responses so far. And this has helped us prioritize some of our options. That includes roof cover, roof sheathing fastening, some elements of the load path. And so this is part of the reason why we've categorized our options in this way. So for the good options, our basic tier of options, these are the options that address critical recurring vulnerabilities. So for asphalt shingle, we're focused on steep slope asphalt shingle roofing. That covers most of Part 9 construction in Canada. We are proposing that buildings could use a Class G or better, ASTM D7158 Class G or better, which really includes most of the asphalt shingles that are being applied in Canada today. We would ask for installation that conforms to high wind installation recommendations that may include 6 fasteners per shingle rather than 4, and shingles with a 30-pound pull-out resistance. Again, many shingles that we're using commonly in Canada to date will meet those criteria. And another important element we're asking for the basic category is a secondary water barrier. So we're expecting loss of asphalt shingles. That's a very common experience with Part 9 construction. So we want to provide a secondary water barrier, something you're probably already doing in many cases. We're talking about a full course of underlayment, and there's several different options that could be applied. But those are the basic options for the recurring vulnerabilities that we see in buildings, Part 9 buildings. We also have an additional category of basic options, and those are options that the building industry is telling us they can do today at little cost and little complexity. And that includes tighter nailing patterns for roof sheathing. So already in the Ontario Building Code, we have a requirement for when you have certain spacing of roof sheathing supports, that the roof sheathing fasteners are placed 6 inches apart throughout the entire sheet of roof sheathing, as opposed to 6 inches on the edges and 12 inches on the interior. So we're suggesting apply 6 inches across the entire roof sheathing panel. And again, that's already in the Ontario Building Code, and Ontario builders are telling us it's not a big problem for them to apply. Another request is fasteners with a bit more pull-out resistance than typically is in minimum code requirements. And that often includes just moving from a 2-inch nail to 2.5-inch nail, or to a twist shank nail. That's something that can be done relatively easily in many cases. And also, the builders are telling us that the roof-to-wall connections are not terribly complex. There's a whole range of options that could be applied. One of the more popular options is H2.5A Simpson strong tie plates. You could use truss screws. You can lap the truss heel with exterior wood sheathing and apply sort of a tighter nailing pattern. There's several options. So that's basically our good category, our basic category of wind protection options. Better builds on good, and that would include an enhanced secondary water barrier, something like taping the sheathing joints as well as a single layer of underlayment, improved roof sheathing fastening, thicker roof sheathing as well, continuing that continuous load path from the roof to wall connection down to the foundation, addressing veranda, open building, post base and cap connections, and some additional measures like high wind resistant vents and siding that are all materials that are relatively available on the market to date. Again, keeping in mind that this is all voluntary, and in the near term, we're expecting more uptake on the basic category of options. We're looking for feedback on this approach. We have some documents ready for review if this is of interest to the group. The standard is already available, but our breakdown, our tiered implementation documents are available for review now as well. So I'll pass it back to Joanne.
Thank you very much. Thank you very much to Greg and to Dan. That is perfect. So I wanted to open it up to some Q&A. There are a couple questions. There's one that went into, I swore I saw one in the Q&A, but I know there's a couple in the chat. So I'm going to read those out. So there was one that came in a little earlier from Peter. While searching metrics, is there a relative comparison on age of homes? For example, new homes. I just lost it. As in 10 years, old, new, 20 years, 30 years, etc. Also, insofar as floods, the age of the infrastructure in specific neighborhoods, streets, subdivisions, and existing storm sewers or street ditches. The same thing with age, with wind damage. Again, better understanding of construction processes and technologies. So I'll open that to Dan and Greg to take that one.
Sure, I can address some of the flood questions. I'll turn the wind questions over to Greg. But with respect to age of infrastructure, for sure, that is a big consideration in all of this work. We know in older neighborhoods, sanitary sewers more prone to inflow infiltration. We have storm sewers that are designed to a lower standard with respect to return period events in older areas. Also, we see a lot of loss in areas that were not very well serviced by stormwater systems, something sort of referred to casually as soup bowls, areas where there's no sort of outlet for water. These are very prone to flooding. One of the important considerations for flood, and we'll talk about that later on, is regions that were constructed between when combined sewers were common and separated sewers were common. And there was a period of time, especially in Southern Ontario, 1960s to 1980s, where we connected foundation drain downspouts to sanitary sewers. Those areas are very vulnerable to sewer backup. So at a high level, yes, we definitely consider that. And we would certainly prioritize older neighborhoods for specifically flood protection options in many cases.
Perfect. There was a question in the Q&A, and Greg, thank you very much for answering that one. It was perfect. And the other question that came through from Andy, it was more of a comment, I think, during Greg's presentation. Is it possible to predict or model the damage potential for windstorms, and are tornado or hurricane or microbursts too random to map out mitigation strategies?
They are not too random. They have patterns and statistics associated with them. Part of the reason we started the Northern Tornadoes Project was to get better statistics, especially with the changing patterns that are occurring across the country. And so we want to understand that in order to make appropriate recommendations. What becomes concerning is when you have changes of storm types occurring over time into regions where they may not be used to it and may not have considered it previously. So we think of tornadoes, for example, as happening on the Great Plains, the Canadian prairies. Saskatchewan was always viewed as our hotspot for tornadoes, for example, but there's very low population density. And we're seeing a shift in the pattern into more tornadoes in Southern Ontario and Southern Quebec, where there's a lot more population, so there's a lot more vulnerability and maybe a lack of expectation that there's anything there. The good news is we can do things about this, and a lot of the mitigation strategies that Dan talked about are relatively inexpensive, and so we can do a lot of things to help. For example, EF2 tornadoes, which are in the range of 180 to 220 kilometers an hour, that's a big wind speed, right? That's a big force that's going on the building. But in Canada, and most of Canada, the snow load is such that for our roof trusses, our roofs are actually strong enough to withstand that kind of loading. All we need to do is now hold the roof down into the walls, hold the walls to the foundation, but our roof is strong enough. So that's one of the benefits we have. And by studying that and getting statistics, we can make recommendations that are probabilistic. The question that I answered was why EF2 and not EF1 or EF3. At EF3, the forces start to get much higher, and so your costs start to go up to withstand it. We can make houses that can withstand EF5 tornadoes. We just don't want to pay for them. Nuclear reactors are designed for EF5 tornadoes. They're designed for a vehicle flying through the air and hitting the outer walls. That's EF5 territory. We don't want to design our houses like nuclear reactors, and we don't want to pay for that, right? And so there's the choices made, and EF2 is a very natural breakpoint where we can capture quite a lot. Basic design wind speeds in Canada are actually in the EF1 range of tornadoes. So when an EF1 tornado happens, we shouldn't expect any structural damage because that's the same wind speed that we designed for. And so it's really about getting the details right for these events, and we've picked EF2 as something that we believe is a reasonable compromise.
Perfect. Thanks so much, Greg. And there was one last question, and then we will open it up to some introductions for the next section. So Livio had a question: how would you assess flat roofs' ability to better withstand high wind situations?
Flat roofs have the highest wind loads, and so they're just gonna have the highest wind loads compared to certain gable and hip. The best shape you can have is hip roofs. Hip roofs they're a little more aerodynamic in shape, so how the flow moves over is a little more smooth, a little more streamlined, which is good. And hip roofs also are very good at distributing the load in terms of how they're made structurally. Plus, they get fastened down onto all four walls. A gable roof or a roof with just rafters, as you might have with a flat roof, will be only fastened onto two walls. And so there's less capacity and less ability to distribute the loads. So flat roofs would be more vulnerable. And just confession, I live in a nearly flat roof house too, and I think about that all the time.
Okay. Thank you so much, Greg, for that. And thank you for the questions. So I'm going to now share my screen because I would like to, just for a moment, actually, really, because I would like to introduce now, thank you for that portion about wind. And now we're going to be shifting over to flood and all things water. So I would like to introduce and give the floor over to Jerry Fairborn, National Sales Manager Commercial at Moen. Thank you very much to our friends at Moen for supporting and sponsoring this workshop as well. So I'm going to stop sharing so that Jerry, you're able to share your screen and take us through, I think, your introduction as well as a little bit of a video too, I think. So tell us a little bit about yourselves and what you do. Oh, and I just have you on mute for a second, I think there. 2 seconds.
All right, there we go.
Oh, perfect.
We're good. All right, can you see the screen?
I can. I just need you to flip into presenting.
Yep. No worries.
Yep, perfect.
Good afternoon, everyone. I appreciate you taking the time. This presentation is a little different in as much as it piggybacks on the flood aspect, but this is really water, but water of a different kind. And it's water that all of us have in all of our homes. And we all know the good things that it does for us, but we never realize how the bad things, if it escapes from the plumbing system, could create for us in our homes. So to that end, I'm just going to do a quick review of who we are. I'm sure many of you may have heard of Moen, but we're part of a larger company called Fortune Brands. Our net sales in 2023 were $4.6 billion. I alluded to the fact that we have water, which is Moen and House of Roll. We also have an outdoors division and a security division with brands known as Master Lock and as well Yale and others. Moen itself is the #1 choice in the plumbing industry as it relates to fixtures or faucets, shower valves, and related accessories. We've achieved that position through thoughtfully designed products that deliver meaningful innovation and lasting value. 67% of consumers can recognize the name Moen. We're trusted 2 times more than our closest competitor, and we're 73% loved by those who know the Moen brand. One of the things that we talk about at Moen, though, is we know water experiences in the positive. I alluded to the experiences in the negative. So part of that innovation strategy we've always had, once upon a time, there was an Al Moen who invented the single lever faucet, and it solved the problem that consumers had with warm water. In other words, how do you create it? So you had hot and cold coming out of 2 different faucets back in those days, and Al solved that problem. We also look at water as a resource that we really have to save or work to from an efficiency standpoint. So one of our goals in our ESG side is to save approximately 1 trillion gallons of water by 2030. And I'm going to talk to you about how we're doing that through the introduction of smart water and the smart water journey at Moen. Back in 2012, we introduced a motionless faucet, followed by a smart shower that you can actually talk to or control with your phone in 2017. We enhanced that motion sense faucet in 2018. And then in 2019, we introduced a product called Flow, which is a smart water monitor and shut off. In 2020, we introduced a smart faucet, smart leak detectors, and then a smart water app to control all of our products as it related to smart water. Up until that time, each of those products had their own individual apps, which quite frankly wasn't sustainable over the long term. We even introduced a sump pump monitor so that you can communicate with your sump pump. I know that not many people lie awake at night wondering about that, but a sump pump, if it doesn't work, can be very problematic. And then in 2025, we're looking at smart property management systems as well as irrigation systems to join our smart water platform. Any questions so far?
None.
One of the things that none? Okay. One of the things that we talk about as it relates to smart homes specifically is many of those homes have security systems, entertainment systems, climate controls such as Nest or Ecobee, lighting, electronics, and appliances. So the smart home, or all homes, are starting to adopt with rapid fashion smart technologies or IoT elements in those products to enhance their living space. However, the one missing element is water. And being the #1 brand as it relates to water and how we use water, Moen saw an opportunity to introduce a smart water product. And I have a short video that outlines details as it relates to the Flow.
An unknown leak hidden behind the walls. A faucet left running. A frozen pipe bursting while you're on vacation. 2 in 5 homes are affected by water damage, more likely than fire or theft, and potentially costing you thousands. Flow Smart Water Monitor and Shutoff is the smart solution to protect your home from water damage. Installed indoor or outdoor at your main water supply, the device constantly monitors your home's water usage. It detects continuous water flow and sends an alert to your phone. With the Smart Water Monitor and Shutoff, never worry about accidentally leaving the faucet running. Even minor leaks can lead to unseen mold and damage. The device detects those leaks and alerts you directly through the app, enabling you to take action. Even while away, when there's a sudden increase in water flow, it sends you an urgent alert through the app where you can shut off your water remotely, giving you peace of mind. The device monitors household water with machine learning to detect abnormalities, protecting your home from unexpected emergencies. Through manual or automatic shutoff, the device prevents the costly headaches of water damage. Protect what matters most with Flow Smart Water Monitor and Shutoff, because when it comes to your home, every drop counts. Flow Smart Water Monitor and Shutoff.
So again, the Moen Smart Water app is controlling all of those smart water products on one very easy to use and intuitive platform on either an Apple phone or an Android package. The device itself controls, and what we wanted to just review quickly is the smart water security products, which make up the flow shutoff, the sump pump monitor, and as well leak detectors that can be added as additional enhancements to prevent leaks within the home. Not so much to prevent, but more to detect and prevent water damage from occurring in your home. And you saw in that video that at 2 and 5 are going to have a water damage claim at some point. Canadians at some point are going to have a water damage claim. Anyone want to guess how big that claim is on average? Not all at once now. We'll come back to that.
If somebody said $50,000, $40,000.
Well, they're being overly pessimistic.
Oh.
The average claim is $17,000. $17,000. And I'll get into some specifics as it relates to insurance in a second. But the Flow Smart Water Monitor is providing 24/7 real-time alerts. It can provide automatic water shutoff if it detects any unusual water use patterns. It's controlled mobily, so you can see and control the flow anywhere in the world as long as your cell phone is connected. And in addition, because it's measuring where and how you use water, it supports our Mission Moen objective from a water efficiency or sustainability measures. The sump pump monitor is added as a device that can turn the sump pump really into a smart water system, in as much as it's tracking water levels within the sump, and it performs and can send alerts to the owner in the event that the pump either A, doesn't turn on, and it does do regular turn-ons just to make sure that the pump is working. So if the pump doesn't turn on, or if the amp draw is not correct, it will send an alert indicating to the homeowner that they need to either service or replace the unit. And it's really around preventing when you most need that sump pump to turn on, that the homeowner is aware that it will do in fact what it's designed to do. It too is 24/7. It makes the pump, again, makes any sump pump up to 1 horsepower smart, and it does provide, again, proactive protection to the homeowner. The lowest level of protection would be a smart leak detection device. It's a standalone sensor that can be placed anywhere in the home, usually around water heaters, dishwashers, refrigerators, anywhere where the potential for leaks could be greater than others. Again, it provides a 24/7 alert, can be customized in many ways, either through humidity levels, temperature levels, and it's also, it's designed to be discreet and compact in its design. As it relates to water leaks specifically, 6 times more likely than fire from the insurance company's perspectives. 6 times more likely than fire. Now 8 times more likely than theft. In fact, it is the #1 claim that insurance companies deal with, maybe not in dollar value, but in occurrences. #1 claim. 40%, as I said earlier, will suffer water damage at some point in their lifetime. 40%. And we also know that those that are using it usually detect leaks in their home and could potentially save up to 64 liters of water. So it, again, addresses some of those concerns, not only for leak protection, but water efficiency and sustainability at the same time. The device itself can detect up to 1 drop per minute. Usually, 60% of homeowners didn't know they have a leak, and within 30 days of installation of the flow, will discover an issue. We also have done some studies. We took about 2,500 homes, and after 1 year, 96% of those homes did not have a water damage claim versus the control group. And those that may have had an incident, the severity was 72% reduced. It's a picture of what the app looks like. It's measuring flow rate in real time. It's looking and monitoring for leaks, temperature, as well as water pressure. So it's using machine logic to measure the flow rate and create an algorithm that's housed on in the cloud, and it creates a water signature for each homeowner's and how they use water on a day-to-day, hour-to-hour, minute-to-minute basis. It's 24-hour water security. It's providing real-time alerts. And most importantly, it is an app-based technology. More and more people who could live without a phone these days. I'm sure all of us could live without a phone if we had to, but I'm sure many of us probably wouldn't want to. And again, going back to that understanding water usage, it's understanding it through a technology we refer to as FlowSense 3.0. It's a combination of machine learning and AI logic that's driving that water use pattern and creating a unique signature for every homeowner. And it also integrates with various other smart home packages that may be available to the consumer. The device itself is installed right after the water meter. There could be a water shutoff or pressure reducing valve, PRV. It's paired to the wireless in the home, and then in turn, it communicates with your smart app or with the app on your smartphone. So that's the installation requirements. The device itself should be on a main water supply line. The line may not be any larger than 1.5 inches. Standard power is required, and again, that smartphone and home Wi-Fi is required for the use to take full advantage of the power of the Flow device. Any other questions or comments? I wanted to stay within the 5 to 7 minutes that we were allotted.
Not a problem. So I'm going to save a couple of the questions, though, Jerry, to the end, if that's okay. There's a couple here.
Perfect.
One was, does the Flow device require an app subscription? I'll ask that
No.
one. No?
That's
okay.
free.
Perfect. Amazing.
No charge.
Okay. All right. So that is good. And Livio has both at his house and they work great. So there you go. You got a little endorsement there too. Fantastic. So this is great. Thank you so much, Jerry, for that presentation. There's a couple of questions. I'm going to leave them till we get to the open floor.
Absolutely.
Too. And I know too that when we get into this next section about flood, I'm sure that Dan's probably going to weave you into the conversation too. But for now, I'm going to share back my screen if that's okay. And I'm going to do an introduction to our next presenter. Gabe Coscarella, who is the president at Mainline Backflow Products and ProFlash Building Products. So Gabe, we're really happy to have you on board. Thank you so much for joining us today. And Gabe, I know he wants to talk a little bit about this one document that all of you will be seeing. I'm going to stop sharing so that Gabe, you can start sharing your screen. And I know too that you're going to actually be kind of showing us a valve as well in your time on the floor. And then we're going to dive right into having Dan talk to us about flood and flood impacts. So I'm sure that your piece is talking about that. So Gabe, over to you for some introductions.
Thank you, everybody. My name is Gabe Coscarella. Back in 1997, I was a plumber by trade. I invented a backwater valve. I thought there was a better need for what we had out there. We needed some better products, and I designed a valve. And 27 years later, we're doing the same thing. And we continue to innovate and come up with new products. And we don't always develop products to standards, but we develop products taking into consideration homeowners, how they maintain, and what they do. So just for all of you guys, some of you guys know backwater valves. Most people know backwater valves as a typical check valve type of valve. Flow through, goes through, and closes behind it. These are considered branch line backwater valves. They're normally closed. They don't let the city sewer breathe. So in Canada, we're only allowed to install backwater valves on the branches if they're normally closed. We came up with a mainline full port backwater valve, like I said, in 1997. It's a normally open valve. Because it's normally open, it allows the city sewer to breathe through the building's venting system. So we're going to talk a little bit about backwater valves in general, what we like about them, what we don't like about them, and give you a quick brief look. As I said, backwater valves are out of sight, out of mind typically. They are installed under the concrete. They require maintenance, and if you don't maintain them, they tend to fail. Standard valves, as you can see, as you push flow through, you're pushing through. Every time you're pushing a door open, your sewage is touching the gate. And when the sewage touches the gate, you have to maintain these at least 2-3 times a year. So we came up with a backwater valve, which is normally open. We take the gate out of the flow, and we're going to show you. We'll share a screen.
Okay, perfect. Are you sharing yours, Gabe, or do you want me to pull?
Yeah, no, we're doing.
Oh,
okay. So here we are, guys. So as you can see, I showed you the normal check valve where the gate is on the bottom. As sewage flows through it, it pushes the gate open and closes. The view on the left, as you can see, the bottom normal flow. What we do is we suspend the gate in the open position, and sewage follows a trough from the inlet to the outlet, and sewage never sees the gate, never sees any moving operations of the valve. The only time this valve ever experiences any sewage is when there's a backup. As you can see, the water come back on a reversal flow on the left, comes into the sides where we have our floats. You'll see a little float under the yellow little thing, and it actually closes the gate. So once the water resides, float drops back down, water flows back out. This is really super important because when we talk about backwater valves, anything that's in the sewage flow, you put a gate in the sewage flow, it's touching sewage, you're going to have to, at some point in time, clean it, maintain it. I'm not sure how many people out there, how many homeowners maintain valves. We would say that there's a high number of them that do not, as backwater valves are out of sight and out of mind. So as you can see in this valve, we have a clear top on it, and we have a little red knob at the top, and you'll see that black fitting there. That's actually a cleanup for the main sewer. So we'll scroll on to the next page. So you'll see the mainline top check features a top suspended gate, which stays forever clean. Even when their city sewer backs up, 95% of what comes back is murky water. It's not really super solid. So we feel anything that goes into the flow channels, there's enough clearance between the floats and how we design it that everything should flow out. But the important thing is that most people don't maintain valves until they've had their first flood. And they'll say, oh, I didn't even know I had a valve. In this case, what we want to do is come up with a mainline top check valve. It'll stay clean and it'll do its job when the city sewer backs up. The little red knob you see up at the top is actually a manual shutoff. You can manually close a valve. So any homeowner, if you're, let's say you're going on vacation, you want to close your valve, you can actually manually close a valve. Any water that collects on the inlet side of the valve will seep through the valve. So we don't have to worry about condensate drains or anything like that. It will seep through it. So if you don't want to rely on your valve to automatically close, you can actually manually close it. Also, if you're at home and you're sitting there in Toronto and we all know when we're watching the TV and we know that storm is coming, we know that cities' streets are flooded, you can manually close it if you like. What you'll also notice, the backwater valves are they're under the ground. So you'll see on the right side, we have an access box. Typically, the valve sits underneath the access box. Usually about a foot below the ground is where they sit. So that gray cover is what you would see on your floor. And at the bottom right, you'll see something called a mainline bladder seal. What that is actually is the valve is installed in the bag, we'll call it. It's sealed on both ends. The pipes go through the actual bag, and it prevents radon gas. It prevents anything from coming up through that valve, water table, and helps them blower door tests for builders, so they're not blowing through the valve itself. Typically, this valve is installed on the main building drain. That means every building that is built, you'll see on the left-hand side, that will have a bunch of exits through some of that system. First thing you need in a house is you need a clean out for the main sewer. And if you are putting in normally closed valves, you're putting them in only on the branches. So that means you could use multiple valves in the system. And usually you do if you're using a normally closed valve. With the top check valve, because it's a normally open valve, it is allowed to go on the main building drain, and you only need the one valve for the entire building. Also, it has a built-in cleanup for the main sewer, so it gives you everything in one. What we find with branch line valves, for anybody is following me on backwater valve side, backwater valves, the branch line valves are typically outside of a bathroom group, in a hallway, or underneath a furnace somewhere. They're just all over the place, and they're not really accessible. So when we talk about maintenance items, we're putting in these maintenance items that are hard to get at and hard to find. So we believe in the mainline top check as being the valve that should be used. We developed this valve about 3 years ago. So we started off with our mainline full port valve that had a gate at the bottom, floated up and closed. Great valve. We had a really good functional valve there. The only thing is the gate's at the bottom. So we wanted to get the gate out of the flow. This is how we developed the mainline top check. With the mainline top check, we also have an alarm system that you could have. You can see this is a typical installation under the ground. You'll see the sensor on the valve, and you'll see the receiver up on the top left. That you can put anywhere in a household. And also with this system, you'll see these little pucks that we have on the right-hand side there. You could actually add multiple pucks throughout your entire building and use our one hub. And that's a wireless hub. Mainline, through the years, we listen to plumbers. So basically what happens is we'll look at codes, we'll look at standards, and we actually change CSA standards with our products. So backwater valves, as you can imagine, they're mechanical devices. They're buried under the ground, and you got to get at them for servicing. So the plumbing code says you can't bury a valve deeper than 24 inches. We came up with the adaptive valve, which is this valve currently in front of us. And I see there's some cities on board. They'll probably know what these products are because they've seen these before. But what they are, it's an extendable body. As you can see, it's a inlet, outlet, and a riser. We don't supply neither riser pipe or the cap at the top, nor do we supply the 3/4 inch pipe within this valve. So we can typically install these things anywhere, and we can install them at any depths. So we get into other valves as well. And we actually don't have all day on backwater valves, but our company pretty well has, we range anywhere from 3-inch up to 6-inch valves. And we work with guys like Dan Sandink with ICLR, and yeah, that's what we do. So we have clear water. So I'll just quickly show you what the actual valve is. Can we switch me? So basically, here's a valve. No, sorry, I gotta be in front of it, I'm told.
It's not gonna work.
There it is. So there's the valve. And if anybody would like a sample or would like to see them, please give us a call. Anybody that has our full port valves in the ground with a gate at the bottom, we actually have a conversion kit. There's somebody wants to convert it to a normally open top check valve with an emergency shut off. We have a kit that actually converts all of them in the ground. So using the same body. And that's our presentation, guys.
Thank you very much, Gabe. And we do pose that question in the survey too. If anybody would like more information or the samples from any of the products for all of our sponsors and partners, we definitely have that in there. So you'll be able to, those attendees, you'll be able to reach out directly and let us know. So thank you so much, Gabe. Thank you, Jerry. And on that note, I'm going to hand over to Dan so that you can really help us dive into flood and the urban flood impacts and basement flood protection options for part 9. I'm sure both of those topics in some cases will weave into this part of the presentation. And then after that, we're going to pause for a little bit of a break. So Dan, over to you.
Okay, great. Thanks. I think it's good that Gabe and Jerry went first because there's definitely some related content there that I can highlight in my talk. So I mentioned before the amount of losses that we see nationally from the insurance industry. This is a chart for Ontario specifically. I think we have some overrepresented or good representation from Ontario. From 2015 to 2024, we saw about $6.2 billion in catastrophe losses in Ontario, similar to what we see nationally. Most of those losses are residential, so personal property, buildings, contents, additional living expenses. And I'm going to talk specifically about pluvial urban flood. And that type of disaster has accounted for about 25% of overall disaster losses in Ontario. So if you take into account wildfire, high wind, hail, and even other components of flooding, like stormwater flooding, sewer backup specifically has accounted for about $2 billion in losses from 2015 to 2024, about 25% of overall losses. So one reason why it's important to consider things like sewer backflow protection. I want to first differentiate the kind of flood I'm going to talk about today. So I think most people think about flooding in terms of river or coastal flooding. So river flooding is a high impact type of flooding, faster water velocities, deeper water. This is a type of flooding that needs to be managed using land use planning as opposed to property level interventions. Where property level interventions are applied, typically it's an engineered solution, like an engineered building that's designed to be with the lowest level living level above the expected flood level. That's something we don't really do in Ontario and Canada. We focus on land use planning. In Ontario, we have widely available flood maps for river flood, not for urban flood, but for river flood. And that's the approach that should be applied. So nothing I'm saying here is meant to make a building in a high risk riverine flood prone area safe for living or in a coastal flood area. It should be that should be managed with land use planning. But that being said, we do have a major issue with extreme rainfall flooding outside of river flood plain areas. And that's what I'm referring to as pluvial flood or urban flood, or typically more basement flood is what you see, the actual mechanism of damage. These are images of some of the more recent events in the Toronto area. On the left is a map. The shaded areas are the Conservation Authority defined river floodplain regulated areas where we do designate high-risk flood areas and zone development out of these areas or require special protection. This is the 2013 flood, July 8, 2013. For that flood, we had access to a good portion of the insurance industry data on claims. The black dots are where we saw insurance claims from that flood event. And as you can see, they're dispersed throughout the urban area, all mostly outside of riverine floodplain areas. And they occurred in areas where we saw high rainfall intensities and stormwater flow rates that exceeded the design capacity of stormwater systems and resulted in infiltration, excess water entering sanitary sewer systems and caused flooding largely in basements. That was a very severe event. In July 2013, there was 126 millimeters in 6 hours. That compares at the time, the 100-year return period for the region was something like 91 millimeters over 6 hours. So way exceeding 100-year return period intensities for the region. And then this past summer, July 16th, we had another very severe event in Toronto, the July 16th storm. The image on the right is rainfall gauge, rainfall accumulation information across the city. And the red dots indicate areas where the rainfall exceeded 100-year return period expected accumulation. So rainfall that was not expected any more than 1% chance per year. And we saw a whole section of the city. So my point here is that even well-defined, well-designed stormwater systems would still be vulnerable to flood from these types of storms. And that's the kind of flood event that we're working toward mitigating with basement flood protection options. Here's another example from Binbrook. And the point here I want to show is that this is a new development. This is Binbrook, just south of Hamilton. In July 2012, they had a really severe storm, 250 millimeters in about 3 hours. And that compares to a 100-year return period of about 100 millimeters. So way beyond 100-year return period. The development with respect to stormwater, as you can see on the left, water accumulated in the overland flow route in the street. But the major problem was what was happening under the ground. So that the sanitary sewer system was overwhelmed, foundation drains are overwhelmed, and sump pumps are overwhelmed. And that's what we saw driving damage to buildings during this storm. So once again, these storms can exceed storm drainage capacity even in new subdivisions. When we have these types of storms, typically there's 3 or 4 mechanisms that drive damage. And they're all treated in terms of mitigation or reducing risk. You have to look at them kind of independently. So first is overland flood, typically related to poor lock grading and drainage, overwhelmed surface water drainage systems. Water flows over the ground, over the surface of the ground, into the building via window wells, cracks in the foundation, etc. Next is infiltration flooding. So this is where the groundwater level exceeds the lower part of the building. So when you get beyond the floor slab, if you've got a high groundwater area or recurrent, seasonal high groundwater area, and also where you have poor lock grading, surface water can infiltrate into the building via the backfill zone, especially over time as the building gets older. The backfill zone around the foundation can settle, and you end up with a low point around the foundation. Water accumulates there and can get into the building, especially if the foundation drains are not operational in an older building, which is pretty common. And finally, sewer backup. So this really gets at what Gabe was talking about. Demonstrating here a separated sewer system. We've got a stormwater system that is filled to capacity. The hydraulic grade line in the systems is higher than the basement floor, and therefore water is backing up into the building. Sanitary sewer systems are not watertight. They leak. There are cross connections and so on that result in sanitary sewer systems becoming overwhelmed as well. And a major driver of loss is sewer backup from sanitary sewers. And if you've never seen this before, and I'm going to throw up a video here. And part of my point here is that we're talking a lot about the costs of the damage, but there's a big, human non-economic element of everything we're talking about today. There's displacement. People are displaced for a year or more, even in well-serviced areas. So city in Barrie, you can still go up there and see some remaining damage to some of the buildings that were affected in the 2021 tornado. About a year and a half ago, I was up there, and there's still buildings that are not completely rebuilt. And that is in a very well-serviced area in Barrie, Ontario. We see smaller communities with catastrophic damage, and people are displaced for years and years, like we saw in Lytton and other communities. And when you have a lot of buildings damaged all at the same time, the cost of repair goes way up due to demand surge. Materials become harder to source. So it's not just the economic impact, it's the impact on families. And one of the things that we hear frequently from homeowners is the impact of sewer backup specifically is a concern. And this is a basement apartment in Ottawa in 2018 where they had a major stormwater event. As you can see, it's a pretty terrifying experience. This person is living in a basement apartment, so it's not just the basement that's damaged to their home. People lose irreplaceable items, and it's just also not a pleasant experience. So we have to remember it's not just the economic impacts, it's the human impacts of these events as well. I also wanted to point out a number of additional causes of basement flooding related to failure of building drainage systems. So that includes sump pump system failure. Ideally, we'd like to avoid using sump pumps. We'd like to gravity drain to a good, well-designed receiving system, but in many cases, it's not possible. And when we do have sump pumps, they are vulnerable to failure. The construction codes don't outline good backup systems for sump pumps. We often see mechanical failure, inadequate sizing, overwhelmed pits. So just excess water coming into that pit at a rate that the pump can't handle. And of course, power outage. When we get these extreme storms, they're often occasioned with power outage as well. Building sewers, building drains, laterals, they can fail. They can become clogged with tree roots. They can collapse if they were not installed properly. Initially, there could be structural defects as well. This is also a major driver of loss. And foundation drainage. So we've done a number of retrofits of homes. In almost every case where we get into a home foundation drainage system that's over 30 years old, it's fully clogged with silt and effectively not operational anymore. Another thing that we know is that we expect with a relatively high degree of confidence that climate change will affect the frequency and intensity of extreme rainfall events that drive these types of events. There's an official method for calculating future rainfall intensity offered by Environment Canada, which you can check out on climatedata.ca. But essentially, for every degree increase in general temperature, we can expect an increase in severity of extreme rainfall events. And if you're building a building you're expecting it to last for 50 years, we're probably looking at a 2.5 degree increase in general temperature, occasioned with something like a 15 or 20% increase potentially in extreme rainfall intensity. So the point is not that we're very precise on these numbers. The point is that we'll see more of these events in the future. So the remaining part of my talk, I don't have a lot of time to get into a lot of depth, but I'm going to draw on a lot of the work that we've been doing at ICLR and with many partners across Canada, including manufacturers, home builders, insurers across Canada, that have resulted in a set of guidelines for basement flood protection. These are all relatively new and I would say untested. And part of our motive here is to connect with the building industry and find ways to implement options that have been outlined in these national guidelines. But this is what we're drawing on for today. ICLR has also been running a sort of a long-going home retrofit program, and I've personally overseen about 20 retrofits for basement flood. So we applied these measures in several buildings and monitored them over time. And we also have an ongoing research project with the University of Guelph where we're assessing the performance of individual basement flood protection options like sump pump systems, backwater valves, and looking at performance and maintenance requirements for those systems. So that's what we're drawing on for the rest of the presentation today. So I mentioned before the good, better, best concept. We're applying the same concept to basement flood protection. The CSA Z800 standard is our baseline standard. It's a very comprehensive standard on basement flood protection. For our purposes today, I'll talk mostly about the high priority, the good or basic options for flood protection. That would include lock grading and drainage, addressing sump pump failure risk, and sewer backflow protection. We'll talk a little bit about the better options with a specific focus on some methods to increase the performance of sump pump systems and backwater valves specifically. And then, of course, there's a larger set of measures that I'm not going to talk about just due to time, but we'd be happy to explore further with anybody who's interested. And I'll also note that all of the topics I'm talking about are behind the property line on the private side of the property line. I also wanted to point out that there are about 40 municipalities in Canada that offer direct subsidies to homeowners, typically focused on existing homes, for many of these sort of basic flood protection options, sewer backflow protection, inflow infiltration management at the private side. And many insurers in the yellow dots here are locations where those subsidies are available, typically in the range of a few $100s to upwards of $6,000-7,000. The City of London's program is one of the more generous ones. It's on the right there. It gives you an indication of how much could be available to help retrofit buildings. I should also mention that many insurers in Canada are offering incentives in some form for basement flood protection, largely focused on sewer backflow protection, improved sump pump systems, sump pumps with backup power, alarms, and so on, like we heard from Jerry earlier. So there are some incentives available for flood protection specifically. So basic options from our side, ICLR, number one basic option is not constructing in known flood-prone areas, and that's something we already do in Ontario. Largely, it's not uniform throughout Canada. We're already doing a good job of this in Ontario. Increasingly, we're seeing better information on other types of flooding, so not just river, but urban stormwater ponding areas, stormwater flow areas. Increasingly, we'll likely look for options that include not constructing in areas prone to stormwater overland flow accumulation as well. Lock grading and drainage, I mentioned this before. For new construction, typically you're already applying lock grading and drainage requirements for new construction that are required by municipalities. For existing construction, where there's work done on the lot, where pools are installed and so on, that lock grading and drainage should be maintained. A big factor for overland flow risk is reverse slope driveways. So as part of our protection package, no reverse slope driveways. Already we're seeing several insurers not offering stormwater coverage for homes with reverse slope driveways. Addressing risk from exterior stairwells. So exterior stairwells are important. They're an important part of sort of the affordable housing push, but they're also a major flood vulnerability. There are some options outlined in Z800 for reducing the likelihood that water will enter basement stairwells and enter the building. So that's also a major concern for flood protection. Another important one is cross connection. So ensuring that the building is not contributing excessive water to the sanitary sewer. So we want to make sure downspouts, area drains, catch basins are not draining directly to sanitary sewers. Many interpretations of the Ontario Building Code, National Plumbing Code, so on, already indicate that this is required, but interpretation varies across municipalities. For our recommendations for vulnerability, there should be no cross connections, no excessive stormwater entering sanitary sewers, unless it's shown to be there's no other choice, like you're reconstructing in a combined sewer area, that sort of thing. But generally, would not be a resilience practice. As I mentioned before, for some pump drainage or foundation discharge, there's a preference for gravity drainage to receiving systems where it's possible. So where the systems are deep enough, where there's some freeboard. So if that system is backing up, it's not going to back up in the foundation drainage system. Where that's not possible, you have to have a sump pump. Some of the good practices for sump pump protection include a selection of better pumps. So we're avoiding column floats, pedestal pumps, because those floats tend to get caught up on different items, the sump pit cover and so on. And so we prefer pendulum floats or pressure switches for those pumps. We also want to make sure that drainage is not causing a problem for neighbors. That's a major issue that we see often. So if there is no option to drain to the surface, if the lot's not big enough, if the drainage is not clearing the property adequately, you may have to look for an option to drain to a down pipe into a storm connection. But generally, we want to make sure that foundation drainage is not creating a problem for neighboring properties. Where pumps are present, they should be supplied with backup power. And I should note that we outlined very clearly in the Z800 standard that we should not be using potable water-powered jet pumps for backup power. They are a potable water backup risk and also draw a lot of water as well. So the preference is for battery backup, and we've got some evidence to show they perform quite well over time. They can operate for several days with the right battery if they're only running intermittently. So battery backup systems, very important. And also the system should be accessible for maintenance. It seems obvious, but in many cases, they're a little bit hard to get at. So they have to be accessible for maintenance as well. We also look for sewer backflow protection, sewer backwater protection, like mainline backwater valves. On our side, we're not going to prescribe the type of valve. The relevant valve for the location, for example, 7464 in the OBC allows for inline valves. If you can install inline valves in place of mainline, that's fine. But there should be sewer backflow protection, and it should be installed according to manufacturer instructions. So we do see some grading issues sometimes on valves. They should be graded. Gabe can outline the grading requirements for some of the valves, but that's an important part of good sort of installation over time. Also providing maintenance guidance for valves, for some pumps, for some pump systems. This is an important part of the resilience options. We know that many homeowners don't know if they have backwater valves. They don't know what some pumps are and so on. These systems have to be maintained. Pumps have to be replaced after 10 years, ideally, and so on. So we need to provide that information to homeowners as well. I'm going to quickly outline some of the better practices and just sort of demonstrate how they're building on the basic good practices. So one of the better practices, so moving beyond sort of the low risk, low cost basic practices is for some pumps, ensuring that some pumps have adequate power for the dynamic head. So we're accounting for the lift as well as the pipe run, the number of joints in the pipe, and so on. The pump has to be adequately sized for the building. For backup systems, we would ask for 80 ampere hour batteries or more. And the idea is to have a battery that can supply power for many hours after a power interruption or during a power interruption for more high flow scenarios. And ideally, and this is a better option, not a basic option, a secondary pump that can kick in the float set higher than the primary pump in the event of mechanical failure. So you've got an alarm, you've got a backup system, but also a secondary pump, just because sump pump failure is such a big driver of damage for homeowners. And finally, some topics related to backwater valves and grading. I know Gabe will point out that I'm showing the older valve, the 4963 mainline valve. Generally, on sewer systems and valves, the steeper the grade, the better, up to about 8%. If you can get a steeper grade on that valve, that's preferred. If you can get a 2% grade on the sewer lateral as well, many builders are doing that by default already, but 2% or more is preferred. It can add cost because the excavation might have to be deeper, but it does improve performance of these systems. So these are some examples of better practices. The list is a bit longer, but it's meant to just sort of introduce the topic. So similar to wind, we have a baseline standard, CSA Z800. It's very comprehensive. We're working with builders and insurers to define tiered options, good, better, best, basic options, enhanced options, and the full package of options. We have some materials available if anybody on the line would like to review. We're happy to discuss and also receive feedback at this stage as well. So that's it for me. I'll hand it back to Joanne.
Amazing. Thank you very much, Dan. And thank you to Gabe and to Jerry as well. And I wanted to, before we throw to a break, there were a couple of questions that came in, and I just want to kind of keep them in there as part of like that flood and that water piece. So a question came in earlier, and it was for Gabe, essentially. Can you put the top check valve on the outside of the house?
You can put the top check valve anywhere, or any backwater valve anywhere. As I said, mechanical devices require access to them. So if we're going to put in a top check valve on the exterior, depending how deep it is, you might require a manhole to get to it. Now we do have the adaptive valve that goes exterior of the building. So we do have valves that do go outside without the requirements of requiring a manhole. So as I said, there's that CSA standard that says 24-inch rule, and we do have valves that we changed the standard. So now you can put valves outside, provided they're extendable valves. So I would recommend contact me and we'll get you some more information.
Okay, sounds great. Thank you so much. And there was a question also for Jerry too. So we'll do that one, and then I'm going to hold on the other question until later. But Jerry, Aaron was asking, while these smart technologies appear effective in combating plumbing issues in housing, are there also practical applications of them in combating flooding or leakage due to severe weather and storms, etc.?
Great question. These are more of a preventative measure for non-weather related problems. Having said that, we do have the ability to detect water ingress with the leak detectors themselves. The only challenge with that is it just basically telling you you've got a problem, but it's not a way of preventing it from the water from entering your home. But at least you know that it is present, and it's a clear and present danger for you. And sometimes people may not know that, especially if you're away, and then you can have someone who's local nearby address the issue, and then it doesn't surprise you when you get back.
Okay. Thank you so much. Thank you. And hopefully that answers that question. So what I'm going to do at this time, I'm going to throw us to a 5-minute break. So it's pretty good timing here. So I'm going to bring everybody back at 2:46, if that's okay, because it gives our presenters a stretch break. I know not everybody's been talking at the same time, but it also gives you, our attendees, a little bit of a moment to stand up, do a little stretch break, do a little bit of yoga, whatever you need to do. And then when we come back, we will be talking about hail and also getting into the insurance piece of things and how all of this ties together. So we will welcome everybody back in about 5 minutes. So at 2:46, please join us back, take a little bit of a stretch break, and we'll see you in a few minutes. Thank you, everyone. And I will share my screen so at least everybody has something to look at for the next couple of minutes as well. So yeah, I will. Perfect. So welcome back, everybody, from that break, a little bit of stretch break, a little bit of hydration. So we're in the home stretch for our presentation. Welcome back. And right now we are going to hear from Simon, who is, of course, the research meteorologist on the National Hail Project at Western University. He's going to talk about hail damage and the available protection options for Part 9 homes. So Simon, on that note, over to you, sir.
Awesome. Thank you so much. So I guess the first caveat here, and as you will all note, the approach or the information that we have on mitigation for hail damage isn't nearly as well studied and as well articulated and advanced as the work that you've just seen for wind and for flood mitigation. However, that does not mean that we don't already have solutions in hand that we can use to address the problems that we already know are some of the main drivers of losses and impacts in these events. So something to keep in mind, but also, again, indicating that we already have solutions that we can apply here, and I'll talk about those at the very end of the presentation. So at the beginning, Dan covered a portion of this where why are we talking about these events? And we don't often think about hail as being an event type or a hazard that generates significant impacts to homes. We'll often hear about it from agricultural areas, damage to crops and things like that. We know it's a problem for vehicles, but we also have very, very large losses that are driven by impacts to buildings and specifically to homes. So here we just have a number of examples of events that I'm sure folks around the table are quite familiar with already. Earlier this year, we had the event Calgary in the north end of Calgary that generated an estimate of at least $2.8 billion in insured losses. We know that a large portion of that is vehicles and things like business interruption, et cetera. But a large chunk of that is, of course, damage to materials, to buildings, and so on. Now, this comes at the heels of another storm that occurred and in fact, there was overlap between the two damage areas. Another storm that impacted the city a little over 4 years prior to that generated $1.3 billion in insured losses. And again, also to indicate this is not just an Alberta problem. Of course, the province of Alberta, we know is our hail hotspot in Canada. That's why we have our field operations occurring there. But we know that hail is a much broader problem across Canada, across the southern and central prairies, as well as portions of eastern Canada. I'll get into that in a second. So another storm that's happened during this period occurred in the north end of Winnipeg in August of 2023, and they're up to at least 285 million in insured losses from that event. So Calgary being essentially the major city that is the hail damage capital, but there are a number of other cities that are also vulnerable across the country. Also, not to talk of the smaller communities as well. So outside of Alberta, there have been also other major hail events. So this is an example here from a rural community of Oak River, Manitoba, and southwestern Manitoba from June of 2023. So hail impacts that are similar in severity and character that we saw in the north end of Calgary, impacting the entire town. And we're seeing this every year as well, where there are a number of small communities that are getting these hailstorms. And what was also surprising to us, even though we study these things, we've been running a research program since April of 2022, and we've been conducting damage surveys, actual on-site data collection of major impacts, really in earnest only started in the summer of 2023. We did 2 test cases in the summer of 2022 to develop our methodologies for this, but then following that, so really it's only been 2 summers that we've been looking at these events in detail and actually making a point of recording the higher impact events. But at the end of last summer, we had 2 events in Ontario, and the folks in the Greater Toronto area should be familiar with some of these locations. City of Lindsay, Ontario, actually technically the city of Kawartha Lakes was impacted by again large hail driven by winds. So this is a case where just one of the eyewitnesses that we interviewed had a 63 millimeter diameter stone that's about the size of a tennis ball that they had saved in their freezer for insurance purposes. And then not 2 weeks later, there was another event that impacted the Pefferlaw and Port Bolster areas. So those are not more than a half-hour drive away from Lindsay on the south shore of Lake Simcoe. And again, we had easily 9 to 10 centimeter hailstones that were reported with this event. And very similar impacts, again, in these storms to what we have been seeing in the Canadian prairies in Alberta and Manitoba and in Saskatchewan. So that kind of caught us off guard. But now that we've also been doing some historical research on these events, we are also seeing that there have been cases in Eastern Canada as well of damaging hailstorms that are significant enough to cause these types of impacts to structures. So what are we talking about when we're talking about impacts to homes? Well, first and foremost, not surprisingly, roof damage is one of the main drivers of damage to and costs of impacts to homes. So here you have an example of a drone image that was taken during our damage assessment of the recent Calgary hailstorm. And if you know, just to orient folks here, we have the north side, or the top of this picture is basically pointing north. So I have a little cardinal indication here on the left. The angle of attack, indicated here by this red arrow, indicates the direction that the wind was blowing during the hail event. So here I'll take a second to step back and basically indicate that at least based on our historical research and the events that we've been surveying, we haven't found a very high impact hail event that wasn't actually a combination of wind and hail. So one of the key components there is the wind will change the angle that the hailstones are falling. So not just falling, but they're being blown sideways. And what that does is it adds a significant amount of kinetic energy to the hailstones. And what we're finding is that you're essentially getting damage to things, in particular roofs, that you would expect that type of damage to occur with larger hailstones, but they're happening with smaller hailstones that have that extra bit of energy, or extra big chunk of energy that's been added by the wind. So to illustrate that, again, you're having winds that are coming in from this direction, from the northwest. We're going to zoom into two sections of the roof. So you have the roof aspect here on what's mainly a hip style roof with the slope, one slope that's pointing basically directly to the northwest. And you can see a couple of things here in this, and I should have highlighted it further with some circles, but basically the type of damage that you're seeing is some bruising. So that's when you remove, folks are familiar with your asphalt shingles. So first you have your granular layer on the top. When you have bruising like this, that's when the granules have been removed. And then when you have these white patches that are now being pulled up, that's when the damage has gone all the way through the tile, or sorry, through the shingle, down to the fiber at the base of the shingle. So all this has to be replaced. But when you look at a roof aspect that is not facing the wind, you have maybe some hints of bruising here, but not nearly as much damage. And so again, what we're finding is that there is similar damage to what you would expect to larger hailstones to generate, but you can get that with smaller hailstones, but when you add that wind component. The earlier case, for example, that I had that I gave also for Southern Ontario, same thing. We had hailstones that were easily tennis ball to baseball size with that Lindsay storm. They were also accompanied by microburst winds of up to approximately 115 kilometers per hour based on damage assessment. So really, we're looking at like a multi-hazard type of thing. Talk about siding. So this here is the same house that we were looking at from the first drone shot, looking directly down. This is, of course, just a portion of the drone image, so that's why the resolution isn't it's a bit lower. But again, wanted to point out. So now we're looking to the southeast, and we're actually looking at the face of the building that was facing the direction of wind. And here we have a good example, even just what you can see from the air, of significant damage to the siding. So here we had black PVC or polyvinyl chloride siding, and that has been basically destroyed to the point where you can see the white underlay here. That's your vapor barrier, Tyvek, or other type of vapor barrier that is again preventing water from getting into the homes. And when you have this severe damage, this level of damage to the siding, you can then have damage to the vapor barrier, which then allows water to get directly into your walls. So to Greg's earlier point about water intrusion being one of the key drivers or kind of knock-on effects of when you have a building envelope failure from wind or hail, again, generating that additional impact. But Also, what I want to point out is that at least here, the neighboring house also had similar type of siding, same class of siding, but their damage was much less severe. So one of the pieces of research that we're working on is trying to figure out why there's these significant differences, even from one house to another. Severe thunderstorm hazards operate on very small scales. And we do expect some significant variability, even on a matter of tens or a few hundred meters. But we're also seeing this over and over again. So we know that some of these differences between adjacent houses is also just driven by the materials themselves. This is a close-up of vinyl siding damage that was generated by a large hailstone. This is in this case it was in Saskatchewan, but again it gives you an idea of what we're talking about. Cracking and basically generating holes in the siding, and then here you have this blue layer, which is your vapor barrier, and then you can actually see through to the insulation behind that. So again, this is where also obviously if you're having large volumes of hail that are being wind driven, you're also dealing with very likely wind-driven rain. So that rain water is also falling sideways and being driven into the home. Just as an example here too of how significant that wind-driven component is. This is essentially a brand new house that was one of the newer subdivisions that was being constructed on the north end of Calgary. They received the brunt of this storm. So just as a quick aside, I don't have the map here, but the storm that impacted Calgary and generated $2.8+ billion in insured losses. It wasn't a glancing blow, but there was a large portion of the damage tract that also occurred north of the city, so that the city didn't even see the whole damage area from the storm. All right, so brand new house, siding has been on maybe for a few weeks, and again you see that similar damage as well as a window failure. I'm going to zoom in on the side here, and then point out if you look at the damage to the siding, you're quite explicitly about 3 courses below the edge or of the roof here. So that gives you an idea of how much sideways component was existing during this or occurred during this event, during the wind-driven event here. And then of course we have what looks like a double pane window that suffered a complete failure as well. So talking about windows, this is also very common particularly in these wind-driven hail events and these high loss hail events, where again you have the failure of usually the first pane in a double or triple pane window, but when it's fairly severe, then you also then have failure of the second and possibly third panes if you're dealing with a 3-pane setup. And then again, that is a direct pathway for debris, for water, for rainfall to get into your home. And also showing this as being adjacent to or when you're seeing these types of window failures, this is the equivalent or the types of siding damage that you're also seeing from these storms. In terms of escalation of risk and what the effects of climate change are going to be, so Dan talked a bit about the extreme rainfall considerations. So for the hail considerations, again, not nearly as well studied, but there is some research that has been published in the last few years. This is research that was led by our executive director, Julian Brimlow, and was the first North America-wide attempt at looking at what climate change effects are going to be on hailstorms. And to describe what we're looking at here, this is a comparison between the number of days per season that you would expect to have hailstones, in this case of 4 centimeters in diameter or larger, so slightly less than a golf ball in diameter, and hailstones larger than that. And we're looking at spring and summer, and it's a comparison between what's going to be the change between our historical baseline, 1971 to 2000 in this case, and projections for the mid-century. And the key result seems to be that the factors that are going to reduce hailstone size are being outpaced by the factors that increase hailstone size in these events. So we think, okay, well, if the atmosphere is warming, then that should increase melting, right? It does, but that only works on the smaller hailstones. When you have more intense storms that are generating larger hailstones, they fall faster, and they're not in that area of higher temperatures nearly as long as they're falling through the storm and then eventually impacting the ground. So it looks like the storm intensification portion is outpacing any kind of melting that you're going to get from warming. So looking at the spring, we have a very weak signal. So the reds indicating increases in parts of Ontario. So again, fairly typical of what we see in the province. It appears to be that your large hail years are going to be fairly episodic. You can go several seasons without seeing big storms and then have a couple large ones like we saw in 2023. But bad news for the province of Alberta. Already a hail hotspot, and it's looking like they're going to be seeing some pretty big increases, especially in the foothills areas, and areas kind of adjacent to and over the city of Calgary, as well as Edmonton area, and as I said, into the foothills regions. So with that, we'll talk about mitigation measures. So roofing, of course, is the main loss driver for residential structures in hailstorms. There are already testing standards for roofing materials in terms of its impact resistance for hail that have been developed. Underwriters Laboratory standard is a pretty key one, and there's also another one that uses ice spheres as a standard. So those basically rate your roofing products based on an estimated or kinetic energy that's associated with different hailstone sizes, that then indicates what type of storm you're being protected from. So we're just going to use this as an example here. The top row. Oh, I should mention. So this is the Insurance Institute for Business and Home Safety, or IBHS. We may have thrown that acronym around earlier. They're a fantastic resource for understanding what roofing products behave or fare the best under these conditions. And they've, among other things, improved and further developed testing methods, including basically building a hail cannon. And so we've been down to the lab there, and they basically shoot ice balls at different roofing products at different speeds to, again, get more realistic characteristics in terms of the failures and behavior. So they'll give an overall rating to the different roofing products that gives you basically out of 4 if it's good or very good. And then they break it down into 3 kind of performance metrics in terms of the types of damage that are resulting from the hail impacts, whether you get dents or ridges, tears in the product, and the granule loss. So the thing that I was talking about earlier, where you're losing that top layer, the protective layer. So they're a fantastic resource for identifying products that are already out in the market that have proven to perform well under these conditions. There are also alternatives. So and again, we understand that there are cost implications, as Dan talked about, for a number of these. If you do want to pay more, or if you have the ability to pay more, there are of course options like having alternative roofing materials. So in this case, this is a house that was impacted in the 2020 Calgary storm, where they replaced their roof with a metal roofing product. And so this is the aftermath of the recent August storm in the same area. And what you're seeing is essentially cosmetic damage to the aspect of the portion of the roof that was facing the hailstorm, but no functional damage. There wasn't any leaks or anything like that. Might have to replace some of the vent covers and things like that, but not the same as having to replace the entire roof when you have, say, a non-impact resistant product and that kind of thing. So there are other roofing material alternatives. And then the thing that I will end with here for the siding question. So I talked about window failures being kind of at the higher end of the hailstorm intensity. So here are other siding alternatives. In cases where we did have single or double pane window failures, but we have wood siding. We have 2 examples of stucco siding here. And this is, of course, concrete fiberboard material. And all of those, what we found in all of our assessments and in so far as these things have been recorded in the literature, that all of these other siding types perform very well in the types of storms. We know that they should have themselves some sort of impact threshold, but it is much lower than the intensity of the storms that we've seen so far in terms of the severity of the impacts. So for siding solutions, there's also the option to have alternative materials for siding, and a lot of the stuff that exists on the market that are these types have shown to perform very well in these events. I don't have a slide here on window alternatives as well, but I'll just mention that there are impact standards for windows that are going to be installed in high wind areas such as Florida, Atlantic coast, Gulf Coast areas. Those provide options for window types or window retrofits that can also help with reducing the potential for the hailstones to break windows in these events. So I'm almost at the end of my time. So what I'm going to do is stop there and see if there's any questions.
There were a couple, actually. So
Awesome.
Simon, so one right at the top when you started, is there a theoretical maximum limit for hail size?
Ooh, that's an excellent question. And our executive director was also part of a research study that looked at that. I'm trying to remember that. and I'll be happy to follow up with an actual a number that they came up to. But I think it's on the order of 25 to 30 centimeters. So these things can get almost the size of an American football, I think was the idea there, and similar shape. So that's an extreme case. But yeah, they can get quite large, and when you're approaching that size, that also explains some historical cases that we've seen in other countries where you have multiple fatalities that were generated by a hailstorm. If you can get hailstones up to that size in very, very rare cases, then that explains how you can get those types of impacts. But one of the things we are looking at, the IBHS, for example, in some of their tests, I think they're getting things like roof deck cracking from hailstones as small as maybe 75 to 80 millimeters. There's some question as to whether or not that's accurate, or if we need, or if it is a slightly larger size when they happen naturally. But yeah, when you get to larger sizes, you do start to see very extreme damage that you wouldn't necessarily expect could occur with these types of events.
Okay. 2 more questions for you then. One from Aaron. How significantly does hail damage affect rooftop solar panels?
Another very good question. And we had actually some cases from the Calgary storm. So roof paneling, rooftop solar panels are also available with impact ratings associated with them. And in the Calgary case, we had a few that were rated to golf balls, so 43 millimeter-ish type of impact, and or 1 3/4 inch. And we also had one home that had baseball size rated stuff. So I believe that's around 2 3/4 inch. And so that stuff performed quite well. The challenge with solar panels is that because it's a brittle failure situation with the glass, all you need is one hailstone to exceed that threshold to damage the panel. So you can have an entire array of panels, and we've seen these where adjacent panels are okay, but then one has been broken, and it's just because that particular panel was unlucky enough to get struck by one hailstone that just breached that kinetic energy threshold. And then when there's a crack, then you don't need as large. You don't need hailstones that are as large or they're flying as fast to then generate further impact damage to that solar panel. So they tend to work very well up to what their design threshold is, but then it's very binary. Then because they're brittle failure, they then switch over to failing very quickly when you exceed that threshold.
Okay, one more. That's great. From George, is there a type of window that has performed better than another during a hailstorm?
Very good question. So, first and foremost, one of the things that we found during these surveys is that newer windows do tend to perform better than your old soda lime type glass windows that we have in much older homes and historical buildings. The Lindsay, Ontario case was a very good example of that, where you have homes that are 80, 100 years old, and the local library and some of the commercial district in the downtown area, also structures that are 100, 120 years old. So all of that old glass fared very poorly. The newer windows, the newer glass does tend to fare better, but we did see failures, and this is something else that we only started recording really later this season, was the thickness of the glass. And in Calgary, we saw glass failure upwards up to at least 3 millimeters in thickness. There were a few locations that had very thick glass in the 5 to 6 millimeter range that did okay. And I think I had another point on this. I'm trying to remember here. The other one to consider is large span versus short span windows. So obviously, if you have a larger span window, there's more room for deflection. They obviously have to meet standards for what that amount of deflection can be. But in general, that seems to be one of the other patterns that we're seeing, is that larger span windows, house windows versus even things that you'd find for hotels. So we've seen areas where hotel windows have been knocked out, but adjacent homes haven't. So larger span windows also seem to be a little more sensitive, I guess, both because of that flexure and also just because simply it's a larger target.
Okay. Well, thank you very much, Simon. Thank you
My
so much,
pleasure.
everyone, for those follow-up questions too. And if any come up during the next portion too, when Michelle's talking, please let us know. And also, as I mentioned, as we wrap up, there will be the opportunity to connect with our presenters. So what I want to do is also introduce now to all of you Michelle Laidlaw. So she's the AVP National Product Portfolio for Home with the cooperators. We're really excited. I know that the ICLR team, as they mentioned earlier, have been working with cooperators. So Michelle would love to give you the floor to do a little introduction of yourself and also take us through some resilience incentives, stronger homes protection. The floor is yours really to kind of help bring this effectively, bring it all together. So over to you, Michelle.
Thanks so much, Joanne. And I'm going to echo all of my other fellow presenters. Thanks for having us here today. We are a partner alongside ICLR, as I know Dan spoke to. So we really want to take an opportunity to share some of the work we've been doing and some of the learnings we've had from this work. So I want to make sure you can see the right screen because I had that kind of flip. Beautiful. Thank you, Joanne. All right, so as Joanne said, I'm the AVP for our National Home Product Portfolio area, and I'm also our initiative lead for our Resiliency and Sustainability Program that is for property and casualty product and claims. So hopefully this is going to work for me today. Okay, so just wanted to share this. This is a bit of a slide that shows a little bit of the story that I know Dan was speaking to. It's a very high level. We're not getting into the intricacies of the detail, but what's really important here is the growth curve on claims. The numbers are the numbers, that's fine, but the growth curve on claims is a problem for the industry because what we would expect on a growth curve for a claims, if it's acting in the way we would want it, is that it would line up with our inflation curve. And the harsh reality is this is nowhere close to lined up. It is much steeper than our inflation curve. And what that's showing us is that frequency and severity of climate-related risk and cat losses is increasing over time. So in a traditional insurance, from an traditional insurance process perspective, what you do is you rate for it and you underwrite for it. So what that means is we increase premiums and we restrict coverage. We have the industry pulling out of different regions of the country that might be high risk. And what this does is it creates affordability gaps, availability gaps, and this becomes an insurance problem. So I don't know if any of you have met our CEO, Rob Wessling, but our CEO is Rob Wessling. And at the beginning of our last 4-year strategy, he really challenged us to say, we must invest in climate solutions on both the mitigation and adaptation side so we can reduce the future impacts of climate change. I'm not going to read it all, but this really took our industry, our organization into a really interesting space, which is where we got to be a little bit more innovative and challenge the status quo. Because if we go back to that other slide and we just apply traditional solutions, that's not a good long-term solution to this problem. So we were put into a space where we got to innovate and we were forced to innovate, and we've developed some really exciting work. So I did adjust the slides because I know we're running short on time, but I want to really focus on the meat of this. And this is the work that I'm the most excited about, most proud of with my team. So this year, we made an intentional step and I'm going to say a very bold step in the insurance space to say we are not going to, post-loss, we will not do what is traditional, which is we take the roofs and all the things that Simon was just showing you, and we say, you know what, we're just going to replace like with like. We're going to say, let's put on the same shingle that we put on pre-loss. We're taking a bold step saying we will not indemnify as we would have traditionally, but we will partner with our clients and we will embed resilient solutions into our claims practices. So what that looks like for us for now is that we are applying up to $3,000 to rebuild with a resilient roof, which will offer better protection against both hail and high winds. We are offering that when we can, we will do hurricane straps to help, again, better protect that roof against convective storm. And we also have some coverage, again, related to some of the water work we talked about earlier that Dan was talking about. related to up to $1,000 to rebuild with loss prevention measures focused on preventing that same loss again. You know, when you saw the hailstorm, you saw Calgary happen in 2020 and 2024. We've seen recurring storms in regions, and we know that we can't just sit back and do nothing and assume that the problem is going to go away. We have to be innovators, and we need to be part of the solution. So this is the first of its kind first coverage of this kind in Canada. There are similar type coverages. What makes us different is we don't. This is not a coverage that is sold alongside our product. This is just how we settle losses with respect to homeowners losses, habitational and farm dwelling. So homeowners, residential, seasonals. So we've taken a bit of a step back in that, saying we know that clients and in communities with our current inflation challenges they're not going to make the decision to buy this coverage. They're going to make the decision to be frank, to not buy it due to the cost that could be associated with it. So we said, let's just apply this across our portfolio. Let's just do this. And so that's why it's first of its kind in Canada. That's why it's bold in the industry, is because this is how we will settle losses going forward. It is designed to reduce losses, and what that should do in the longer term is to reduce our claims costs and keep insurance affordable and available. Obviously, we need scale, we need size, this is not going to be something that we see a return on in 3 years, 5 years. This is a 10, 15, 20-year return for us. But we're investing, and we're investing to build resilience in Canadian homes. The other piece I'll add really quickly is some of the research we did from a client perspective reinforce this concept, where if people are given the choice between purchasing this coverage and not, to be honest, when they're given the choice, they will choose to not purchase it because there's so many challenges with respect to pricing, and we know this. We see that every time we go to the grocery store. But what we also found is that there's an expectation of the Canadian communities and Canadians that the industries around them are acting differently, innovating differently, so that they're creating solutions that are easy to absorb. And that's really why we headed down this path. Really excited, very proud of my team for this. And it's an area of focus. And I know Dan and I have other meetings where we're working with industry to really influence this direction. Next steps for my team are really to push the needle further, to say, what else could we do? Is there an opportunity for siding work? Are there fire smart items that we want to consider? You know, I know there's fire smart items out in BC and Alberta that are really prominent for wildfire risk. Are there additional flood mitigation tactics that we can use? So we're not done. And then the incentivization piece is that we really started to focus on, as we scale, what does this mean to the reduction of loss, and how can we incentivize from a pricing perspective? We know that that's the hot button topic, and we're looking at applying pricing methodology that will incentivize the right resiliency behavior in Canadian homes. So I know I said a lot really, really fast, but I wanted to make sure I got this part to all of you. So I'll pass it back to Joanne.
I appreciate it. Thank you so much, Michelle. And I don't want to rush you, because if there's other information, I know you sent your entire presentation too, and you may have edited a couple slides, but I will tell everybody that you're going to get the whole piece. If there's 1 or 2 slides that you hid, everyone's going to get access to those. And so they will be able to, everyone, I encourage you to reach out to Michelle too, if you have any other questions really as it relates to the uninsurance piece. So this was really wonderful. And I don't see any questions right now in the Q&A area. However, I do want to open it up and just ask if anybody has any questions for any of our presenters as we go through this and as we are wrapping things up. But I also want to make sure that I have shared my screen with all of you, and you'll see a little QR code up there. So I want to say this is your chance, which is unusual, to pull out your phones, and please scan that QR code, because we would love your feedback. It is also an opportunity in that survey. It only takes a few minutes. You will receive a URL link when you get the thank you email for participating and attending. But there's a couple of areas in that survey that are going to ask you whether you have any questions directly for our panelists, and if you have that you want to be contacted by them so that they can actually follow up, assist you with any of the questions that you might have. If you want to pointedly send anything directly to them, we'll make sure that those get to our panelists. But on behalf of our team here at EnerQuality, I want to thank sincerely all of our panelists, all of our facilitators. I want to thank cooperators and Moen and Mainline for making this possible. We really do appreciate your support with our education and training workshops. I also want to thank the research from the academic side as well. So Professor Greg Kopp, to Simon Eng, and to Dan Sandink, thank you so much for putting all of this information together. And for any of you who have any direct questions on the academic, the research side, please do also let us know. We'll make sure that that information is accessible to all of you. So thank you everyone for tuning in this afternoon. We're wrapping up just in time, which is fantastic. I'm not stalling for more questions, but I just want to leave it open here in case anybody has any questions, even if our panelists have questions for each other about any of the information that was shared. Does anybody have any questions? I'll stop talking for a sec. No? Oh, wait, there is a question here. Yay. So Michael, with regards to wind resiliency, has any testing been done on non-vented soffit panels? For example, currently it's typical to use vented soffit around the entire house. I don't know if that's for Greg.
I'm sure someone's tested it. I mean, soffits used to be solid plywood. Venting has an advantage of probably reducing the loading overall on the soffit panels, especially for the suctions. One thing that does happen, and I've seen this in labs testing for hurricanes where you have wind-driven rain, the soffits can be an entry point for wind-driven rain in extreme events like hurricanes. That would tend not to be an issue for the kind of homes we have, or for the kind of storms you have in Canada, but is a major issue in hurricane regions.
Okay, thank you. Thank you for that question. Okay, so as we wrap up, again, thank you everyone for your time. We really do appreciate it. As I said, you will be receiving an email later this afternoon that will come out from our team. And I know that all of you, great participation. We really do appreciate all of your time and dedication to pulling this kind of presentation together. It's definitely a relevant topic. I know here one of the expressions I've been using this summer is that the weather is getting a little bit more aggressive. It's aggressively raining, or it's aggressively snowing, whatever, it's aggressive heat. So we are dealing with definite climate changes, and it's affecting our homes. So thank you all very much for a wonderful afternoon together, and we will see you again next time. Thank you so much.